Good morning, everyone. Just give us one moment. Okay, he's in. Good morning, everyone, and happy Friday. Thank you for joining us today. Today we have Denny Group with us. He is a consultant here at Improving in the Houston location. He will be leading this discussion. Before I hand the mic over, I wanted to let you, our viewers, know about the Q&A feature located on the bottom of your screen. If at any point you have any questions, you can post them here, and Denny will be happy to answer them for you. And without any further delay, take it away, Denny.
Okay. Thanks, Jordan. I appreciate the introduction. Welcome, everyone. Thanks for spending some time on your Friday here with me. Today, what I want to talk about, I'm going to go ahead and share my screen here. I want to talk about build once, deploy anywhere. And this talk was born of my effort to understand some of the oddities that I was experiencing as I was working in my current project. So I had been working on this project. We were using Azure as our environment. I'm doing the front end development. We're using Angular. And we'd get to the end of some of our sprints and I would deploy to our Azure environments, and I would notice that for most of the time, it did exactly what I wanted it to. It would connect to my development resources, and I would see my development application running. But then there were these times where I wanted to move it to our production environment, and it would still connect to development resources. And it's very frustrating. And the whole Azure and cloud computing realm for me is a bit overwhelming. There's a lot to learn there. Every time I log into a portal, whether it be AWS or it be Azure, it just seems like there's an overwhelming amount of options and services, and I don't know what these pet names are for the different services. And so knowing what I know, which is the Angular world, the front end world, I work with these tools and around these tools often with cloud computing, but I realized I didn't understand some of the nuances to them. Didn't know enough to figure out how to achieve what I wanted to achieve. So early in the project, I had set up my project so that I was able to develop locally and point to different environments, whether they be development environments, production environments, or my local environment. But then the transition to getting that to work like I wanted within the Azure world was something that was breaking down. So I went about over the course of 2-3 months or so trying to figure out how can I understand what's going on and set this up, and how can I get this to function like I want it to when we move to the Azure realm. So what I want to share today is the documentation that I put together to cover that for you. So first objective I had when I set out a few months ago was I wanted to retain that configuration that I had set up, which was the ability to support building my Angular project for connecting to local environments, a development environment, or a production environment, whichever I wanted, right? So I didn't want to lose that ability in any of the reconfiguration I did. But what I wanted to add was the ability to configure the project in such a way that I could build one thing, just run one Angular front-end product, and be able to deploy the output of that, the artifact, to any of our Azure environments, which in our case, we had 2 separate ones, a development environment, and essentially what we consider to be a production environment. To do that, I had to first take a step back and just review in my own head, well, what are we doing when we're building and configuring software, right? So how are applications in general built and ready to run in different environments? And so what I realized is that, well, in software development, we have these times, right? We have these 3 basic software phases as we develop. The first is the development of the software. We're writing the application code, and we're configuring that code via XML files or text files. The second software time is the compile time. That's when we convert that application code into some kind of machine code. And that code is packaged or bundled for some type of execution environment. And lastly is the runtime phase, right? This is where we're actually using the application. The application has to be loaded into some execution environment and then the application code can be executed from there. And tightly paired with that is configuration. So there's two types of configuration that occur. The first is compile time configuration. This is the configuration that will dictate what kind of debugging inclusions to have. So when we are in development mode, we might want to include things like source maps so we can step through our code and figure out what's not working. We also want to maybe configure what's the log statement severity that we want to report to our server logs. We also have compiler settings like optimization rules. How small do we want our bundle to be, right? Or linting enforcement, that's language intelligence that says, well, how strictly do we want to adhere to certain conventions that we've established through team or group or through industry. And then we also dictate where the output, the executable for our compilation is going to go. So that's part of the compile time configuration. And then we also have runtime configuration. And with runtime configuration is once the application is actually running in that environment, where does it get its data? Which database do we want to connect to? Does it want to be our production database, our test database? And then maybe which URLs to access. They might be staging service providers or production service providers. So that's part of the runtime configuration. And then there might be like tenant theme settings that will dictate, what colors are used by the front end. So that's our software configuration. And then ideally that configuration is what we call externalized. And what does that really mean? Well, to think about that, let's consider not externalizing our configuration and instead hard coding our configuration right in with our application code. So that would mean that within our application code, anytime we want to output a log statement, we're going to point it to our dev environment, right? We're going to have pointers to data sources like our database, that's our dev database. Maybe we have development images we're pointed to, those are resources. All those are hard coded right in there with our application code when it's not externalized. And of course, when we build that and compile that, the product is going to be a build that's highly tailored for our development environment. Now, if we wanted to do the same for production, we'd have to go back to our application code and we'd have to find all those places where we've written our dev logging statements and replace those with production statements. We'd have to connect to a production database with our database connection string instead of to our development database string. And we'd have to update all of our resource pointers throughout our source code to point to production resources rather than our dev resources. Now imagine we want to switch back to dev environment. Well, now we got to go back and revert all that work again. So we can see how unideal it is when we do not externalize our configuration. When we do externalize our configuration, we write our code in a way that knows where to find and how to apply settings. So the application code does not have direct knowledge of what our configuration settings are, but instead our application code knows where to go find that information and how to apply it. And when we do that, we can have our build configuration values in some external file, like a text file, an XML file. And then when we run our compilation, we'll end up with an artifact that is just a generic build artifact produced using those values. And at runtime, similarly, if our code knows simply where to find runtime configuration values, well, the same build artifact can be used in different environments, and the code will go find the dev values versus the production values. So in both of these cases, we can see that those settings are read in from external files or an external source, that the external meaning it's outside of the application code. Our application code does not have hard-coded references directly to those values. So what does this look like in our project? I have this front-end Angular project, and I wanted to see, well, what am I doing in each of these phases, each of these software times specifically? Well, I'm writing my application code using the Angular platform. So that means I'm writing code using TypeScript, which is a superset of JavaScript. and using node libraries to implement my application. And then configuration is occurring through some Angular platform setup files and just conventions that are used through with Angular development. They've been established over the past decade or so. So we'll take a look at that a little bit more later. And then when it comes time to compiling my front end, that's where we convert the application code into something ready for a machine. Well, I use what's part of the Angular platform, which is the Angular CLI, the command line interface, which is just a tool. It's designed to give me a command that I can run to invoke the TypeScript compiler, which is like a transpiler that will take my TypeScript, remove types from it, and produce some JavaScript files. And then it also does bundling of those JavaScript modules. That's Webpack, and that's all part of the Angular platform. It's simplifying that for me. I simply have to run this compilation, tell it to build my project, and it will output something that is a set of JavaScript files. And it also does that bundling as a web file, a single page application set of web files that can be ported onto a web server so that our application can be hosted on that machine. So that's all done during the compilation step in my case. And then in the runtime, the application's loaded into some execution environment. Well, that's just those files being placed onto a server. And to execute those, that's simply the web server pointed to those files as a document route that will answer any incoming HTTP request from browsers. So that's the runtime for the front end part of our application. And with Angular, any Angular project has built-in support for this compile time configuration. And there's two areas here. So anytime we start or create a new Angular project, it will come with these three files. There are two environment files. One is for development, for just local development. And the other one is intended for use for production. So on the left-hand side there, we can see there's a placeholder for us to set and establish what are the values, the environment-specific values that I want to use in a development environment versus my production environment. Here we can see there's simply a flag that says this is production build or not. Now that is coupled with this Angular JSON file on the right. That's a configuration file that tells the Angular command line interface how to select from among those environment files and which ones to include when you actually build the project. And so these come right out of the box with Angular, and this is what we were using as well in our project when I started. I think maybe the equivalent to this on a C# perspective would be your debug and release configuration files. And then for runtime configuration, Angular provides a hook. So we can exploit this. This is a convention that's used in the Angular world, which is Angular allows you to tell it if you want it to do certain work before rendering its first page, right? So there's a thing called app initializer, and you can say, all right, Angular, once you download all the bundles to the browser and you're ready to start running and providing access to the users, before you do anything, do this step. And so we tap into that in our project and point it to a external file called config.json. And in there right now, we simply have one setting, which is just where do I find my resources? Where's the back end to support this particular front end? And so that's how we have runtime configuration currently implemented in our project. And these are the target environments we have set up in our project. We want one for local development and production. And notice on the local side of things, we're simply pointing to a local host environment. This is a C# server running on our development machines. And then the front end is just a conventional Angular localhost at port 4200. So when we're just doing our initial development, this is the most useful environment for us. Now, when it comes time to move to a development environment, that back end is actually hosted in Azure, and so is the front end. So this is moving to the cloud. our development environment. And similarly with production, that's also a separate environment. It also has a couple of dedicated production resources. So those are the target environments we're trying to reach. And to do that, we have these sets of files. We have an environment file in our Angular project for each one of those to point to a particular target environment. And then we have a matching config file that includes the pointer to the URL that is required for that particular environment. So you can see here, localhost points to our localhost selection, production points to the production environment. So this is how we're accomplishing build and runtime configuration currently. And what this looks like when we actually go and build our project, we simply run the Angular CLI, ng build. We select one of those environments. The application, the Angular application, when it starts up, it hooks into that app initializer that Angular offers us. It contacts a configuration service that we've provided, and that configuration file knows which one of these versions of config JSON to read in. And only then does the application then start to contact the back end that's required for that particular environment. So in general, again, how does this work? Well, we run a command line statement to select an environment, tell it what to build. When we start up the application, it's going to select that file. And then the application from then on out will use that pointer to that base URL from that configuration file to determine how to reach its backend resources. And this is what it looks like. So when we actually build this on our local machine, we see that the Angular compiler will use the Angular JSON, the proper environment file, and it'll produce those static website resources. And this is because our application is designed as using our classic web application architecture, where we have our application is produced and delivered to our users through a web browser. On the web server, we are hosting the application files. The web server has access to some system backend. As a user tries to contact our application, the web server will respond with that Angular compiled files, and we'll end up rendering the application. So for localhost, when we run it in localhost, the web server itself, and this is a key thing I had to recall, is that this is still functioning this way when we build for localhost, where we're contacting a web server. But the web server is provided by Angular as an in-memory web server. So it's a little bit transparent, right, where those files are being hosted. But that's what's happening. We still have this client to server request, and then via our configuration, it'll be pointed to our localhost backend. When we build for dev environment, it's also going to be hosted locally on a local web server. It's going to point to our development environment. When we run a test setup, we just simulate the backend, and so we just have our local web server. But then things change when we get to our production build. And so when we just run a build of the project, the product is simply a set of web files to be deployed to some web server. They don't go anywhere inherently. And this is where we have a deviation from how we build locally to what we want to reach when we move it to the Azure environment. So roughly building locally, we start it manually by saying, yes, we want to build something. The compiler from Angular is going to use our source code, and it's going to produce that set of web files. And these are the different versions of this we've seen. And first three cases, we're both building and deploying the application, deploying it to a local in-memory web server, but it is being deployed. But lastly there, we're just building, and we're not saying at all where those output files go. And if you notice here, each one of these build events is tailored for a single runtime environment. So this was when I realized we have a tight coupling already between what we select to build and where we intend to put that output file. And this is one of the issues that we were facing that was preventing us or blocking us from the deploy anywhere type of scenario. So to get this files into the Azure environment, we need to host our files on a Azure resource. So Azure, one of their services is called a web app service, and that's what's used to host or provide a web server for your applications. And this was the scenario for our dev environment that we were looking to achieve. We just want to have a dedicated development URL where we can access the website. It'll know how to access the development backend to support it. And similarly, the production environment would have similar files and simply be hosted on a production URL and know how to reach a production backend. But when I reviewed this, I realized that we were not simply hosting our static files. Instead, we were hosting a containerized version of our application. This was something that was set up on the project before we started. And so had to figure out, all right, well, what does a container, how does a container fit into this? And these are Docker containers. Docker is something that I've had a little bit of experience with, but typically was configured and set up by DevOps or some other resources. And I was simply focused on implementing the Angular pieces. So I needed to learn what is the impact of this containerization for our application when it comes to building and deploying into our environments. So first thing I discovered was that Azure services have not just the web apps or web app service, but they also have a web app for containers service, which is a slight variation that allows you to host one of your containers within similar system. So what is a containerized front-end build? That's the first thing I had to discover, and notice that in our repository, we had always had this Docker file as part of our source control system, right? So the file was always there in the project. It is version part of Git. And what happens is when you use Docker and use its Docker build command pointed to that file, it'll produce an image. And an image, a Docker image, is kind of like a recipe for what is it required to host an application, host and deliver an application, right? So a Docker file will contain instructions on how to build the project, like the application, but it also includes details on what are the supporting dependencies that your application may have. So in our case, we have a set of static files, web files is all we're really producing when we run ng build. What does that require to actually be useful, to actually run? Well, its dependencies are, it needs to run on a web server, right? So we need to have a web server. The other thing is that web server needs to run on some kind of a machine somewhere. So where's that going to run, right? And so the Docker image gives you the ability to specify what kind of machine you want, what exactly do you need on that, in this case, a web server, and then what are your application products? What is the artifact? What is the resources it needs to run? So you can actually specify all that in an image. We'll see that. So I did open up our build file, and we don't have to detail all of these steps, but I want to highlight a few things that are in the Docker file about how it works. So the first thing is you start off with some kind of an operating system. And in our case, it's a Linux operating system. And then you tell the Docker file, well, what do I want to base my image layer on first, right? And so ours started with Node. And so Node allowed us then to take our project files and install them like a front-end project, right? So our front-end project Angular depends on Node. You have to have that installed if you want to run the Angular CLI compiler. You have to have that installed if you want to install your Node modules to support your project. And so our Docker file actually goes through those same steps where it says, okay, grab those dependencies. You can see on step 4, we're running an NPM install to get all the Node modules filled up that our application is going to need for installing the Angular CLI. And then on step 7 there, we actually pull in the Nginx, and this is a web server. So we're saying we're also going to need this web server here. And so if you look at those steps there, the resulting image, the resulting recipe says, hey, you're going to need to have a Linux OS. You're going to have an Nginx web server, and you're going to have the compiled application files, which is our Angular build files that we looked at initially. We can build locally as well. And so the end of this process after running Docker build Dockerfile is an app image. But if you notice here, when it builds our project on step 8, or actually step 6, you'll see that there's one statement there that simply says build, right? So here's another area when we're trying to build through Docker that we've got a tight coupling between what gets built, right? Well, how do we influence where the runtime settings are for this? We don't really have any of that information here. And so this was another area which needed to be explored to figure out how we might be able to build one thing and have it deployed to different environments. But the image itself that we were producing all along has these 3 main elements: the Linux operating system, the Nginx web server, and our built files. So when we actually move this to our dev environment in Azure, it looks similar to what we initially saw with the static web files being hosted, but we're actually hosting an image, or actually the Azure will use our image and start up a container for it and host that. And we have one of these for our development environment, and we also have one for production environment, right? So we look at the building for Azure, it relies on that Docker build statement. So the trigger here, when does building occur? Well, instead of us typing in npm run or ng build and selecting a specific environment, the cloud, our setup, our project setup is designed so that anytime we merge new code into our master branch, it'll automatically build for us, which is pretty convenient. It's automated, and there's an interpretation then that occurs after that. It's going to use that Docker file we took a look at, and it's also going to take a look at another file that we had in our source code repository, which is an Azure Pipelines YAML file. That Azure Pipelines YAML file is tightly coupled to the next step there, the builder, the Azure Pipelines build. And this is a service provided by Azure. When we log into our DevOps project on Azure, you'll see setup for these pipelines. And this will influence that YAML file that will influence what steps the Azure Pipelines build process takes. But the result is what we discussed, which is we're going to have an image that's going to have our 3 parts in that. We have this container that's highly tailored to support and deliver our application in the most efficient way possible. So the event here that triggers all this is just merging into the master branch. Even here, though, we're not deploying anywhere. We're just producing an image. So key thing to see here is that we simply produce this image and we actually store it in a registry. I'll show you this depiction here is pretty close, but within Azure, when you log into the Azure portal, we see references to this build pipeline. The Azure build pipeline gives you the ability to specify variables if you want. It produces that app image, which is a deployable artifact. And what our first step did, our build step or stage, it does 2 things, which is to build and push. And the push just means pushing it into a storage place for later use. So key thing is it does not deploy anything here, but we are saving that somewhere, and we're saving that in what's called a registry. In this case, it's the Azure Container Registry, but I believe Docker Hub itself is also considered a registry. A registry is kind of like a package controller package, kind of like NPM for Node. It's a repository of packages or reusable pieces of code. But in this case, a registry will house container images instead of like Node packages or something of that nature. The second stage, how does that actually get into an environment? Well, you have to use a second half of that pipeline, which is the deployment part or the release pipeline. And that is set up in our system to take out the image from that repository and then actually push it into either a development environment or a production environment. The troubles here is that when we look at the Angular project environment file, we realized, and the support that it has built into Angular, is that it's only build time, right? We only have the ability to influence environment values when we actually build the project, the Angular project. The runtime configuration that we had in there was tightly coupled to whatever we select right when we build. It has no knowledge at that point of where you're going to place these output files, right? We can host these locally in our in-memory web server. We could host them on our some other web server, or we could actually try to put them into Azure, but there's no knowledge of where that eventual destination is going to be. And so that deploy anywhere is lost as we build the project from the Angular standpoint. The second part of this is the Docker file, the blueprint that we're using to tell it how to build and configure the application for Azure. It's also just a single file, and it only has that one build scenario built in it as well. There's only one thing, one place there, one step where we tell it which environment to build for. And so neither of these innately were capable or ready to support multiple environment deployments for one specific build. So at that point, I went looking for solutions and I searched online, and one solution to consider was specifying multiple build pipelines in Azure. Okay, so when we log into Azure DevOps, I could see that we had one pipeline that was set up for our user interface, and we had one pipeline that was set up for the backend. And we could split those user interface pipelines into two. I could design one to build for dev and one to design for production. And this would be one option, right? In each of these cases, I would take each pipeline and point it perhaps to a different Docker file, right? And we'd have two different Docker files, which would then in turn create two different Docker images. And then I could maybe steer the dev image to the dev deployment whenever that occurred, and the production image to the production environment. So that'd be an option. But when I reviewed that, I thought, well, I'm still building twice in this case. So it's kind of violated the goal I was after, which was to build once and be able to deploy that thing anywhere. I'd have to produce multiple artifacts, multiple images, and try to manage that. And then I would have to try to make sure I'm always mapping the right image to the right runtime environment. So this would contain a lot of management on the DevOps side. And so I went looking for other options. So the next option that I found was to maybe use those pipeline variables that Azure offers and set up an argument in there and plug that into the build stage of the pipeline. To do that, I simply have to modify the Docker file so that instead of having a hard-coded ng build environment, I could say, well, instead of saying ng build for dev or ng build for production, I could have ng build variable environment, and I could plug that environment in through these Azure pipeline variables. So certainly a good option. But I noticed in that case, I would still be building twice, and I'd still have to manage two different images, one for development and one for production. And then I'd also have to set up, I think, some deployment pipelines that were dedicated for either dev or production as well. So that didn't seem ideal either. So I'm still building twice with the multiple artifacts. I still have to worry about how to map these things. So next, I considered doing something else that I had seen some online help for, and that was maybe we should just abandon the use of the containerized solution altogether, and just instead host our application on the default web app services. And if you recall, when we're building for a container, it's the Docker file that's used that really declares exactly what is built. It builds an app image, and that app image is funneled to a proper environment based on the release pipeline. But if we eliminate that containerization step, we could instead just set up the build pipeline within Azure to use its tasks. And we could run through those Azure tasks, and we could use those to simply run commands like npm install and then ng build. And we could use that, and we could certainly make this work. Instead of creating a container image, we would just produce our set of web files ready to go into some web server environment through our release pipeline. So that was an option as well. To make that happen, you would have to, again, create a couple of different pipelines, build pipelines, dedicate those tasks by environment, and then also saw, and this was again something I found online, the suggestion to use this external marketplace task tool. So these are tasks, the pipeline tasks that you can fetch that are not produced by Microsoft directly, but one of those was recommended to use for this kind of work. And what that would involve, the first option was what they call a tokenized runtime configuration. So I would rewrite some of the configuration pieces within the application code to tokenize the values that need to be changed depending on runtime environment. And then that would go into the dev build pipeline in Azure. And we would use this third-party tool, this task called the replace tokens task. And that could go into our tokenized config file and replace the token with an actual dev URL, for instance, in this case. And what happens is then it goes and replaces that. Then we can build for that environment. It produces files that have a config JSON file that has the development environment URL already baked into it. Those files actually go back into the pipeline, and then eventually that gets deferred out into the release pipeline to reach the dev environment. Another way to, well, this is an example of what that looks like for production. The npm task notice is the only thing that changes. We would have a config switch there to tell it to essentially use the production environment values instead of the development environment values. The second way to use that same task that I saw recommended was to have a multi-stage build pipeline. And in this case, we start similarly, still have tokenized source code. We switch it, we specifically tell it to build for that scenario instead of, for instance, our local host or production environments. It produces those files, again, the static web files. They go back into the pipeline build. And then there's a second stage. And in a second stage where we actually go to deploy it or put it into a development or production environment, it's at that point we use a different task called extract files to pull those files back out of the pipeline, then replace the tokens by looking at the main.js file. And if you're familiar with the bundles that Angular produces, you'll recognize that the main.js file is one of the standard output files that an Angular project creates. And so the recommendation here was to use this replace tokens task to go into that final output JavaScript bundle and find your token and replace it with the value you actually want to use for production or development. And then that could eventually go directly or be deployed into the proper environment. So that was the other option that I saw. And there were several things I didn't like about this. First of all, we're building twice, right? Still not the build once that I was targeting. And we still have multiple pipeline maintenance or this multi-stage build pipeline. So that was changing a little bit from what our client had put in place already to start with. We have to map those images to the right runtime environment. We would lose those benefits of containerization. And this is really the biggest drawback. Right now in our project, we're not doing a lot with containerization, but the plan is we will lean on it quite a bit. Some of the values of containerization, not just the ability that what we're using right now, which is to be highly efficient in your final output product, but also to be highly tailored towards exactly which dependencies you want to use. So we got those benefits. But the other benefits come as you scale. When we want to open this up to many, many different users, we can hook a container into a Kubernetes or some kind of orchestration system where the orchestrator can monitor for us and help us make sure our application is always highly available. If something goes wrong within a container, an orchestration software can actually recognize that, shut one down, and pull up another image, can spin up another image. So we would lose a lot of those benefits. Plus, this was just against what our client preference was. So they didn't want to deviate from this containerization system. So I didn't really want to do that either to solve this problem. The other thing I didn't like was that with the replace tokens task, it did not feel proper in my mind to go into output compiled code and try to manipulate that prior to deployment. So that didn't feel quite right to me. And then we had, of course, this additional complexity of adding these marketplace tasks, which, as we know, when we depend on anything, that dependency could change over time. And that would be another area within the project that we'd have to monitor if we got outside of Microsoft's built-in tasks. So these were the drawbacks that I didn't like about this solution, although this did work. And so I started thinking, what's the alternative? You know, what can we do that's outside of what I've seen so far? And I thought to myself, well, is there anything I can do to influence the runtime environment within the container itself? And if we remember, the container has just these pieces in it. The first is our output Angular files that we compile. And these are going to be pre-built Angular files, but as we've covered, those are going to be attached to a specific environment. So the environment's fixed at that point. Then we also have this Nginx web server. And I knew that with a web server, we have the ability to configure routing, right? Configuring routing simply means when a URL request comes in, where do you want to serve that from, right? So by default, that's just going to point to the document root. But I knew that within web servers, you have the ability to do redirecting. So maybe we could leverage that. And then, of course, lastly, we have the Linux, the operating system. And I know that Linux, this is really the host system for our web server and by extension, our Angular application. It's really providing the environment whenever this thing is running in the Azure Dev or the Azure production services, right? So I know that this operating system has environment variables, and I thought, well, maybe there's something we can exploit with that. So as I did some research, there were some key discoveries that surfaced. And the first was, we know, and we've seen this early on when I did the local builds, we know that anytime we build an Angular application, we can specify a particular build configuration, right? So we could point it to one of our config JSON files to be applied at runtime. So I knew I could rely on that. Secondly, within Azure pipelines, I ran across some documentation at some point that mentioned that the pipeline variables are published into containers as environment variables. And this was key because then I knew I could actually declare or dictate what information is recorded as environment variables inside the container, right? And then lastly was with the Nginx configuration, I did learn that since version 1.119, and by the way, when I started this, I was on version 1.17, but slightly after that, they added the ability for the Nginx server to access environment variables. And then I knew from past experience that with any web server, I know I can specify redirects. And so with that information, I'm going to go through here using the text, what the solution, I'm going to describe the solution via text, and then I'll show you a drawing to kind of show it. But I knew if I could combine those three things, maybe I could come up with a solution to build once and deploy anywhere. And the first is, I could build an application destined for this Azure deployment with maybe no environment specification. So I could, instead of, as shown early on, declaring a target environment right when I build the project, I just was going to leave a blank space. So this is similar to tokenization. It would just be, this is not going to, there will be no pointer, no information yet for where you get your backend access, that I could build it in that manner so that it was an empty pointer at the time that I actually built the Angular application. And instead, if I were to run such an application or try to run it, the front end would always say, well, it's undefined. I don't know where to get the data from. But I could build it under that context, right? Then I knew I could introduce pipeline variables to provide this information about whether or not I'm actually trying to release to the dev environment or production environment. And I knew that Azure told me it will publish those as environment variables into the container. And then I knew that if I could build the Docker file with custom web configuration, I could do a redirect maybe. And instead of having the application read the file that had no information about where to reach its backend, I could maybe force it to redirect to a configuration file that had the proper runtime information based on where it's currently running, and really based on to which Azure environment it had been deployed to. And so to do that, we could simply leverage the container startup process to look inside of its own container for its environment variable to figure out which config file to actually read in to find that URL. And so what this looks like in the setup is at the release stage. So imagine we have a build stage that has already produced an application image that, excuse me, that has no information about its runtime environment. But when we go to release it, we have a pipeline variable set up that says anytime you want to release to dev, your API source is going to be DEV. And anytime you want to release to production, the API source value will be prod. And this is done in the release pipeline. And when this container is deployed into that environment, we can see that if you start on the right-hand side here, the Angular application files, they will look to the, they'll be hosted by the web service, the web server, the Nginx, right? When a request is made by the Angular application file to get its configuration at simply config.json, the web server will use the environment file to figure out to which config.json file should I actually redirect that request to. And so now, when the Angular application starts up and makes its request for configuration, for runtime configuration, the Nginx web server is going to redirect its request from a file that has no information contained into it to the appropriate config file that has a pointer to the actual environment it's been deployed to. So this is what it looks like in the development environment. And in production, very similar, that initial request to grab configuration will simply pull that information out of the environment file, figure out which config file to redirect to, and use that file instead. And so if we look at the whole picture of build once, deploy anywhere, we're still using the Docker file that builds a single Angular image that points to a generic config.json file without any information in it about its runtime. And that is what ends up in the registry, the image registry. And that's the build phase of the pipeline. And then when we go to deploy it to either dev or production, at that point, the Azure pipeline variable will complete the process of configuring the container with what it needs to tell the application where to find its config. And so this is the final solution that we did end up using. All right, that is all I've got. We do have maybe a little bit of time for any questions. If not, I will thank you all for joining and giving me your time, and I'll turn it back to Jordan.
Thank you, Danny. That was really awesome. We don't have any questions in the chat, so I do encourage our viewers, if you have anything that came to mind, this is a great time to ask it. I did personally have a question for you though, if you don't mind. This was a really good overview, and you went into a lot of detail of like how the whole system works. A lot of developers stop at the deploy button. No one kind of really looks into what that does, and this is a great overview of all of that, really. And for a lot of our viewers, and for me, how do you go into like starting to learn and pick around those areas and those settings? Do you have any resources, or what was that process like for you?
It was lengthy and also kind of overwhelming, right? Because just with cloud computing in general, I have found that it's changed a lot it changes rapidly. There's a lot of information out there. And what I have discovered is it's often difficult to figure out which content applies to my specific case or not. And so there has been a lot of trial and error, especially with the pipelines, moving through that and testing things out. It was a slow and tedious process for some of these scenarios. Finding blog articles to advise is something that I did look at as well. And then one of the things that helped with this was getting with somebody who had some more privileges within the Azure portal, so I could see how some of the other pieces were already set up. So visibility, I would encourage, if you have the ability to access the actual Azure portal environment and explore and look around, that can help. Scouring the internet, I don't have any resources that come to the top of mind to point you to directly, but it was a lot of exploration and a lot of experimentation to get to this level of detail, which is also why I did document it here, because I needed to recall it myself, because it was so much work over a span of time, on and off, right?
I know, from the developer standpoint and lightly touching DevOps stuff, there is a lot of like articles and resources that are online. People do post like how-to guides for a
Yeah.
lot of stuff, and it's a good entryway. I think we did have one question in the chat from from Russ. He said, great session, nice setup, excellent exploration sections, and very nice overall. His question was, did you try to substitute values directly into the files during the release pipeline without using containers?
Directly, yes, I think that not into the release pipeline, but in the build part of the pipeline, I did try that, where essentially you pull out the source code, and directly in the source code, you could do the replace token step there and produce an artifact, right? But at that point, again, that artifact is locked into one of the two environments. So I did not try it in the release phase. Does that answer your question?
That makes sense to me. Not sure, Russ, if that didn't, you can post another one. But as of now, that is all we have in our Q&A section. Just give people a couple more seconds if they post anything. He did have a follow-up. We normally do this in the release phase, but have just started looking at this for Angular apps. Right. Well, if you do have any other questions, okay, one more comment. Works smoothly for C# APIs, so that would be the path we were looking at. Okay, that's an interesting take. Well, I do encourage you, if you have any questions or want to follow up with this, you can always reach out to me or to Denny. We're always available to kind of direct you or answer any questions that came up. Otherwise, do you have any closing statements, Denny?
No, just thanks for attending. I appreciate your attention. And yeah, if I can help, just to echo what you said, Jordan, if I can help anyone else get there quicker, understand something, I'm more than willing to try to share what I know and what I've learned. This is it's a big world, the cloud computing, DevOps, trying to figure out how Angular fits into that is definitely a world to try to clarify. So yeah, if I can help at all, just let me know.
All right, I'm gonna post a link to where this will be, where the recording for this will be available in our chat. Just give me 1 second while I do that. Okay, so thank you, Denny. This was really a great talk. We're always happy to have you on here. And to everyone on the call, thank you for joining us today. The recording for this session will be available on the next business day, so that is this Monday. And that'll be available on our virtual events page at improving.com/virtual-events. I did post that link, so take a look for it on Monday. Please keep an eye for our next virtual lunch and learn. We have one every Friday from noon to 1, and we look forward to having you join us next time. We will not be having a lunch and learn this Friday for Thanksgiving. We'll be taking that Friday off, but first Friday in December, 2nd. All right, everyone, have a great weekend and happy Friday. Thank you.
Thanks.